This is problem 11 from chapter 15 of the textbook Stats Modeling the World by BVD. So for this problem, it looks like we've been given two categorical variables. So it looks like if we were randomly selecting from this population of males, American men, if we asked, do they have cholesterol, high or just okay cholesterol, here's the distributions. And then if we ask, do you have high blood pressure, or what is their blood pressure, it's either high or it's okay. Alright, so sometimes it's tempting to go ahead and just add these up so we have them ahead of time. So this would be 27.27, and this would be 0.73, right? And that should add up to 1. And if we go across this way, that would be 0.32. And if we add this way, it would be 868, right? You can always check by adding that in both directions they come to 1. Okay, so let's see if we can do these probability problems. So, what's the probability that a man has both conditions? Okay, so he has high blood pressure. So you can sort of just see from the table that it has high blood pressure and high cholesterol. So we would write, let me do this. We would write probability of both conditions would be 0.11. And that's pretty much all we have to do for that one, because we're using from the table. That should be sufficient notation. Alright, so let's look at the next one. What's the probability that he has high blood pressure? So the probability of high blood pressure. So from the table, he could have high blood pressure and high cholesterol, and he could have high blood pressure but okay cholesterol. So it would be this subtotal right here. So it would be 0.27. Okay, so 0.27. Alright, let's look at number C. What's the probability that a man with high blood pressure, so he has high blood pressure, has high cholesterol? So here you have to interpret this as a conditional probability. We want to know what's the probability of high cholesterol. Given that the person has high blood pressure. Okay, so we might be able to look at the table and just figure it out, but we want to remember that the probability of A given B is equal to the probability of both A and B divided by the probability of the given. So here, if we use this formula, then we'd want to know what's the probability of high cholesterol and high blood pressure. And we would divide by the probability of the given, which is the probability of high blood pressure. So I think we already answered one of them, didn't we? What's the probability of both conditions, right, is 0.11. So once again, of both conditions, 0.11. So we would have 0.11 divided by the probability of high blood pressure. Well, that was the one we found right here, probability of high blood pressure, right? High blood pressure, 0.27. 0.27. So then you just use your calculator, and I get approximately 0.407, or 40.7%. Okay, so that's how you do that. It's a conditional probability. Let's do the next one, the last one. What's the probability that a man has high blood pressure if it's known he has high cholesterol? So what's the probability of high blood pressure given he has high cholesterol? So very similar to the last one, we're going to use the same formula again. We're going to go, that's going to be the probability of both divided by the probability of the given. So that's going to be the probability of both high blood pressure and high cholesterol divided by the probability of the given, high cholesterol. So this is, the top part is the same as the one above, so it's going to be, the probability of both is 0.11. Now what's the probability of high cholesterol? Well, it's, you can have high cholesterol and high blood pressure, or high cholesterol and okay blood pressure. Could be either one, so you have to add those. So it's 0.32. So 0.32, and if we do the math, we can say 0.344, I believe, and so that would be 34.4% if you want to use percents. So in both of these cases, since you're given the table, you can use the table, and you don't have to use this notation. You can say from the table, and you can write out sort of your logic, and I would probably answer the question. So that's another way of doing it. But what I'm trying to do is get you used to using the conditional probability formula. Okay, that's how you do that problem. Good luck.